Welcome, class. We're going to talk about solving systems of word problems today. When we're talking about writing word problems, we need to go back and review the words that we're looking for to tell us when we're writing adding, subtracting, multiplying, or dividing. So we have addition, sum, plus, increase by, more than. Subtraction, difference, minus, decrease by, less. We're going to add to the multiplication. We have product times twice would be multiplied by 2, squared something to the second power, cubed something to the third power, and then we're also going to add the word of. And then division, quotient, or half, for example, would be taking half of something, dividing by 2. So a third would be 1/3 of something, or dividing by 3. Let's take a look at these examples and write what we see. Anytime we have a number, we're going to take that and write a variable for it. We can use any letter we want except for the letters E and I. And there's specific things E and I will represent later on down the road. So we want to avoid those two if we can. So maybe for this, I'll pick A. So a number A minus, subtract, 2 times 8. Times thing there. And we're done. Letter B, the product of 6 and a number. So product means we're going to multiply. And I'm going to pick B for my number this time. So 6B. Remember, we have a letter and a number right next to each other. We usually don't have to write a little multiplication symbol in between it. And we don't want to use X for multiplication because now we're using X's for variables. Letter C, 9 times the sum of a number and 5. So this is telling us that we want our order of operations to do the sum first and then multiply by 9. In order to do that, we've got to have a set of parentheses. So we have the 9 on the outside for 9 times, and then the sum of a number. So this time I'll use C for a number. Sum means to add, and then 5. Now we're going to talk about our word problems. So these are going to be system of equations word problems, and I'm going to apologize because we're going to come down in here, and I think I got a little carried away. This Wendy should really be Michelle. And again, I apologize for that. So we're talking about April and Michelle working at Wendy's. Together, they worked 68 hours this week. Well, first we need to figure out what it is they're actually asking us to do. They want us to find the number of hours each person worked. So we can use, again, any letters we want for variables except for E and I. And we're going to replace April and Michelle with variables. Many people like sticking with X and Y, but you could also use A and M. So I'm going to use A for April and M for Michelle. So if together they work 68 hours total, then that's going to be an addition problem. April and Michelle work 68 hours. And then it says April worked. I'm going to do April worked 10 hours longer. So 10 hours longer than Michelle. Now we can find how many hours they worked. So we can use substitution or elimination. This problem, because we have April here all by herself in that equation, is set up already for substitution. So I'm going to plug this in here. We have 10 plus M plus M. So this is what April was. And then the plus Michelle is equal to 68. I'm going to combine my like terms to get 2M. Subtract the 10 over. And then divide by 2. And we see that Michelle worked 29 hours. I'm going to plug that in to our bottom equation over here for April to say 10 plus 29 gives us April working 39 hours. One last part to word problems that we need to do is we have A is 39 and M is 29, but we need to write down what that means. So April worked 39 hours. And Michelle worked 29 hours. And then that problem is finished. Now we're going to talk about Daryl selling school play tickets. I'm going to go to the very end of the problem, and they're asking us the price of adult ticket and a child ticket. So I think I'm going to use A for the adult ticket and C for the child ticket. On the first day, so this is going to be my first equation, we have 3 adult tickets and 5 child tickets for a total of $27. So 3 adult and 5 child is equal to 27. The second day has 9 adult and 5 child tickets for $51. So 9A and 5C is 51. Change my color here. So I could, again, substitute or eliminate. By eliminate, I'm going to multiply this top equation by a -1 to get -3A minus 5C and -27. So now when I add them together, 9 minus 3 is 6A. These add to 0. 51 minus 27 is 24. Divide both by 6, and A is 4. Now I can take that and plug that into either one of the original equations that we wrote. I'm going to plug that into the top one. 3 times 4 plus 5C is 27. 3 times 4 is 12. Move the 12 to the other side, and we have 5c is equal to 15. Divide both sides by 5, and we get c is equal to 3. So finishing my problem out then, we say adult tickets are $4 and a child ticket is $3. Now we're going to go to something a little different, talking about just two numbers. So again, we need variables for each number. I'm going to use x and y this time. So I'm going to say x is a number and y is another number. The sum of two numbers is 85. So x plus y is 85. The difference, so we're subtracting x minus y, is 11. Find the numbers. Well, this problem is already set up for elimination. 1x plus 1x is 2x. 1 plus negative 1 is 0. And 85 and 11 is 96. Divide by 2, and we find that one of our numbers is 48. Plug that into either one of the original equations. I'm going to go ahead and plug it into the top one. 48 plus y is 85. Move that 48 over, and that gives us y is 37. So one number is 48, and the other number is 37. And that'll be it for our notes today. We'll see you in class tomorrow. Have a good one.